All right, guys. Good evening, and um, wherever part of the world you are, states. Good morning, good afternoon. You're welcome to the second day of this series, and without we're so glad to have you guys. And without spending much time, we'll be having our facilitator for today. So, Etete, over to you. Thank you.
Okay, can you hear me? Can you hear me? Yeah. So good evening, guys. I don't know if anybody can hear me.
Yes, I can hear you, sir. Good evening.
Well, that's fine. So good evening and welcome to. All right. Thank you. Awesome. So good evening, everyone. Welcome to Ethereum's Nigeria series on account abstraction, three-part series on account abstraction. Yesterday, we looked at, of course, the overview of a smart contracts, an account, and all of that. So today we're actually going to dive deeper into account abstraction and actually do a little hands-on on account abstraction. But just before we start, right? So let's get an understanding of what account abstraction is and why it's really an innovative solution, right? So prior to account abstraction, when I say change the state, I mean to actually interact with the blockchain, and of course, from the blockchain and to the blockchain rather. So earlier, before account abstraction, we only had to use our externally owned account. That's the private account we have, the ones that comes with our private key, right? So this is useful, but in production stage, when we're talking about many user application. So imagine that every time.
Okay, so uh, there's a technical hitch right now. Uh, let's let's just bear with us while he tries to join. Um, so while we're waiting, if there's any question, like maybe from yesterday's lecture or anything, feel free to just maybe ask. Then let's take it up from there.
Yeah, sorry guys, I think my network is, so I had to change my.
You're welcome back. You're welcome back.
Thank you very much. So back to what I was saying that imagine having to do all these transactions like using a decentralized application, maybe a website, and every time you try to change the state of the blockchain, it gets the pop-up, you have to sign the transaction and all of that. Compared to what we have now in the Web2 space, where of course users can use websites and application without actually worrying about always signing and all of that. So account abstraction kinds of like is it actually a smart contract, right? So what this smart contract does is it takes the burden of or this experience, this poor experience where users have to be signing transactions all the time, and it does that on behalf of a particular account, and then you can actually use with this concept, you can use the decentralized application more efficiently. And of course, there are other benefits to that. Like for instance, you can have your smart account, in this case, or like there's what they call like a paymaster. That means that you don't have to pay gas for interacting with the blockchain. So imagine sending a transaction and you're not paying gas for it because your smart account is actually handling that. Of course, either the smart account or the paymaster. So all these benefits are actually it's very innovative because earlier, if we look at the history of account abstraction, you realize that of course it started with Vitalik, and then the concept was they wanted this account abstraction concept to actually be implemented without changing the underlying technology of Ethereum, right? So when we're having like all these Ethereum improvement proposals, right? So sometimes they need to like have a fork, a hard fork, where they have to, after some consensus, of course, where they have to like update some things. So account abstraction actually works without changing the underlying technology of Ethereum. So let's look at it. Let's look at from the source, right? So it's always good to verify. So I'll just share my screen now. Yep. Okay. So I hope you guys can see my screen, hopefully. So let's go to EIP 4337 is actually the Ethereum improvement for account abstraction. What's that? Okay. I don't know why that happened. It's in EIP or ERC. EIP 4337. Okay, sorry, ERC 4337, EIP, I think. So let's look at what the concept of smart account is. So actually, let's read the docs, right? So we always read documentation, which is important for every protocol, right? So looking at the documentation, right? So we see that the account abstraction is a specification that aims to use an entry point account to achieve account abstraction. In this case, the entry point account handles, of course, validates the user's transaction and also sends this transaction on behalf of the externally owned account. In this case, your account that has the private key, right? So if we look deeper, this like the concept, they also have what they call the bundlers. There are different components that make up account abstraction, which we are going to look at in a while. But then you see, it takes the user operation, and of course, that's taking all the, for instance, the user is trying to interact with the blockchain, right? So every function, every operation the user is trying to send to the blockchain, right? So instead of sending directly to the blockchain, the entry point does that, validates that, okay, this transaction is coming from this user. And of course, this user is allowed to do this transaction. And then the entry point takes this transaction, sends it to the smart account, and the smart account executes this transaction. So yeah, you can also look it up yourself, erc4337.io/docs. So if we look at, let's try to understand it so that we look at the architecture. So like I mentioned, these are some of the components. We have the user operation, and this user operation, of course, like I said, a user trying to send transactions to the blockchain, right? So normally they have what they call a bundler. Now, a bundler is like an optimizer, right? Because it takes multiple user operations and sends it in one transaction. So you can, instead of sending one user operation at a time, the bundler can actually bundle these transactions and then send multiple transactions and multiple user operations in one transaction. And of course, the entry point, of course, you will scroll down, you see, of course, yeah, the user operations, execute transactions, and then the bundlers package these user operations into the entry point, and then the entry point handles the verification and the logic. And then we have an account. This account contract is actually our smart account, the one that actually does all this stuff. But then there's an account factory, which is like an instance of the smart account. And we'll look at all of this. Then we have a paymaster. The paymaster, of course, is there to, like, for instance, pay gas fees on behalf of the externally owned account. So, of course, this is their documentation, and feel free to go through them. I think I have a chat. Okay, I think that will be sorted out then. So, and then, yeah, So we can look at all of this, and then they have a GitHub page here, where if you go to their GitHub page, of course, you see the implementation of smart account. Of course, this is done by It Infinitism. So, of course, this is their GitHub page. And then the most impressive of all is that they actually have an NPM package we can actually use, which of course we'll use in the course of this class. So moving forward for this part of our series, remember we said it's a 3-part series. So for this series, we are actually going to look at how we can actually create a user operation and then have our smart account execute our user operation on our behalf. So this means that this execution will be sent from, we'll send this transaction from our externally owned account, and then our smart account will handle this transaction, send it to the entry point for validation, and then the entry point will then validate these transactions for the smart account to actually execute it. And of course, remember I said it's a 3-part series, so we'll also be looking at the paymaster later on when, of course, we have the paymaster pay gas on our behalf. So without much ado, I have a file. I think I have, yeah. So please, I hope you guys can still see my screen right now. All right, so we have I have an empty folder. So we are going to initialize a Hardhat project, and we are going to use our Hardhat project to actually implement this. For those that are not familiar with Hardhat, you can go to let's see, I think hardhat.org. Now, Hardhat is actually a framework that allows developers to actually build stuff and test smart contracts, right? So yeah, it's a Ethereum development environment. So we're just going to look at, yeah, like I mentioned, for those that are not familiar with Hardhat, you can go to Hardhat, of course. I don't want to accept you. The installation and all the processes of setting. Okay, let's just follow what they say, right? So I know the first thing we have to do is to initialize our project, right? So we go back to our folder, and then yeah, so we're going to initialize our Hardhat project. Okay, I trust you. Yeah, please, I hope you guys can see my screen. Can you guys hear me?
Yeah, I can hear you. It's visible.
Yeah, all right. So you can see my screen. I'm on VS Code. I hope so you can see. Yeah. So the first thing we are going to do is bring up our terminal and then initialize our Hardhat project. So the first thing we do, let's go back to I know it's npm initialize, but then let's follow the manual, right? It's good to follow documentation. So the first thing we're going to do is initialize our project. So yeah, so just do npm initialize -y because I don't want to fill in anything. So it's
Sorry,
going to
sir. Sorry, sir.
automatically
We're not
create.
seeing your VS Code. We're not seeing the VS Code, but we're seeing the your Chrome or your search.
Sorry about that. I'll just stop sharing. Yeah, let's try that again. Our Chrome. Yeah. Okay. All right. So you can see my VS Code now, yes?
Yes, thank you, sir.
Yeah, it's
All right, awesome. So like I said, the first thing I did was to initialize our project by running this npm initialize why because I didn't want to fill this up, right? So it's just going to do that for me automatically. So the next thing we're going to do is, of course, we're going to install our Hardhat, of course, to enable us to develop. So if you are using Yarn, there's a command for Yarn here, and you're using npm, there's a command for npm. So yeah, we'll just go ahead and then use this. and then run it, try to install our harder project. It's going to take a while. So yeah. So while that is on, after of course initializing our harder project, we are going to use the account abstraction package from its infinitism, right? So remember when we came here, its infinitism. So we are going to, they have a node package. I think let's see, npm account abstraction. Yep. So yeah, they have the account abstraction slash contracts, which we are going to use to actually build our smart account. So yes, so they have this. So we are going to still install this package here, npm install account abstraction slash contracts. So all right, our yes. Okay, our hard is still installing, and after did somebody say something? Okay, I think I'm having network trouble now. Oh, not today. But let's just install this, and while that install, okay, it's installing now. So I'll just go, feel free to go over to erc4337.io, check out the documentation for account abstraction, and of course, at your leisure time, do how to go through it. And yeah, so okay, I think our hard hat is almost ready. So the next thing we do after, of course, installing our hard hat package is to run an npx command. So we'll go back to, of course, our hard hats. Remember, I said we'll just follow the documentation. So we're going to run this command here to initialize our hard hat project. Hopefully, yeah, so successfully installed hard hat. And then the next thing we're supposed to install is our account abstraction package. Remember, yeah, the node package from account abstraction, so that we can actually call on the entry point, and of course call on the they have we look at our node model. So they have what they call the core, and in the core they have their entry point, they have the I account, they have some interfaces, and you can do a lot with account abstraction, right? So there are a lot of functions that we can call. But for today, our focus would actually be on the user operations, and of course the entry point. So yeah, we have that. And if we come over to our node models, you see here we have our account abstraction. And if we look into the core of the account abstraction, this is what I was saying. We have the base account, the paymaster, the entry point, some helpers, some nouns, managers, the sender, creator, and a lot. So we will just be using some functions from this core, but you can do a lot more with it, right? So, okay, I think we have that. Let's look at a package.json. Yep. So the next thing we need to do is to initialize our hard hat projects, right? So we initialize it with npx. I wish I could hide this. Yeah. So npx hard hat initialize. So we're actually going to initialize a JavaScript project, although I love working with TypeScript. So yeah, we initialize a JavaScript project, and then yeah, it's asking us for the root directory. Yes. Then gtid no. Yes, we want gtid no. Then yeah, we need to install this package. Nomic Foundation is a tool that is going to actually help us use Hardhat to interact with the blockchain. And remember, of course, for those that are familiar with Hardhat, And those that are not, Hardhat is actually a development environment. So it means that we can actually run a local node, a local blockchain node on Hardhat. And of course, for developers, we can use this for building stuff, for testing stuff, and all of that. So while we wait for that, I think that's the last thing we are going to actually install. So yeah. So we'll wait for that. But let's just go through a few things. After we initialize our project, we notice that we now have a folder for contracts, scripts, and of course tests. And if we look inside the folder, of course, there is this lock.so. Of course, we're not going to use it anyway. So it's just a smart contract that comes with when you initialize your Hardhat project. So I think, well, just wait for that. Let me look at some charts. You'll get it on this. Okay, all right, awesome. So we won't be using our log.so, right? So what do we do? Do we rename it? I think we should just delete it, right? So we'll just delete that. We don't need that. So, but what we do need is our own smart contract, which is of course going to be our smart account. So let's just name it smart account, right? Smart account dot so. So yes. Okay. So yeah, we've gotten that, and of course, as always, we start with, of course, specifying our identifier license. Identifier, I think we just use MIT. Yeah, MIT, of course. Okay, awesome. So we have everything we need for, let me just look at, yeah, we have everything we need to actually start building our smart account. Okay, awesome. So yeah, let's go back to our documentation just to confirm a few things. Remember, in the architecture, we have the user operations, we have the bundler, we have the entry point contract, and then the account contract. So if we go back to our node models and then look at our package we installed, account abstraction, we are building the smart accounts, right? So of course, here we have what we call the base account. Yeah, and it has some function. And you check, you see that the base account is inheriting from the I account here. So we'll take a look at the I account. Yeah, so if we take a look at the I account, I think it's in interfaces. Yep, yeah, interfaces. So we take a look at our I account, you see that it only does one function, right? So it validates user operation, right? So that's the only function of our I account. So and we're building a smart contract. Remember, we say that our smart contract is going to, of course, the entry point will validate this transaction and then send it to the smart our smart account. And then our smart account can actually then execute and, of course, validate this user operation and execute it. Of course, the team also did well to comment. They have a lot of comments here, and of course, it explains the code. But what I want us to look at is that to validate the user operation, right? So we need to pass in the user up. We need to pass in the user up hash, and then we need to pass in the missing account funds. Now, of course, these are well explained. The missing account funds here is the funds on which we are going to deposit. If you look at the documentation here, right here, says is the fund we are going to deposit in the entry point, right? So that once we have these funds on this entry point, normally in a more standard way, the paymaster is where we are supposed to send the funds to, right? So, but since we are not going to implement a paymaster today we are going to implement the user operations and then, of course, the entry point. So what we're going to do is we're going to send user operations from our externally owned account, and then these operations are going to be sent to the entry point, and the entry point will validate it then send it to the smart account, and the smart account would execute it. So I think I've been talking. So let's just let's start, right? So the first thing first, we need to declare our Solidity compiler version. For those that are not familiar with Solidity, of course, there are different compiler versions. So normally in Solidity, first you have to declare the compiler version that, of course, you want to compile your code with. So we're just going to declare a compiler version for, I think I like 0.8.9, yeah. But I know that right now we have up to like, I think the latest Solidity version is, I think, 0.8.24, I think, yeah. 24, yeah. So, okay, back to our smart account. So the next thing we're going to do is we're going to import our module that is going to help us, of course, interact with this. So we're going to we are implementing the I account and the entry points, right? So we are going to import those two. So we're going to import at account abstraction. I think so, contracts. Yep. So we need the I account first. Yep. And then we also need the entry points. Entry point, yeah. So, okay, that's awesome. All right, so then we can now say start writing our smart account. Let's say smart account. Of course, it has to be I account. Why is it I account? Now, if we go back to I account or so, remember we need to validate our user operations, right? So that's why we need the I account to be able to validate user operations. So our smart account is actually I account. I account. Yeah. Of course, yeah. So for our smart contract, I'm looking at just a very simple smart contract. And what we're going to do is we're going to just change the state of the blockchain. And then we're going to have our smart account change the state of the blockchain. And then we'll verify that we actually did change the state of the blockchain without using our externally owned account. So to do that, we are going to look at a simple operation where we just, of course, we can have a function that would increment the counts for us. So let's just say we'll have a state variable. Let's call it counts. It's going to be unsigned integer, and we'll just call it count. Let's declare it public, and we have unsigned integer count. Unsigned integer means that, of course, we are talking about only positive numbers, right? So then we have an address. So later on, I want us to check to confirm that it's actually the smart account that is actually executing these transactions, not our address, of course, that is sending the transaction. So let's just have an address for the owner. Yeah, so I think that's all. Then we can pass this owner in our constructor. The constructor is actually the first function that runs once we deploy the code, right? So it's going to be the first function that is going to execute. And of course, it's going to initialize the address that deployed the smart contract as the owner of the smart contract. So yeah, so we say that our variable owner now becomes the one we passed in, right? So I think that's that, yeah. So, all right. So the next thing we're going to do, we're just going to have a simple, like I said, just to change the state of the blockchain. But before that, we need to, since we're importing the I accounts, right? So we need to have a function that validates user operation. And if we go back to, Why are you not? Okay, I account, I think. Oh, okay. So if we go back to I account, we are going to implement this function, right? So we're just going to implement this function. So we'll just copy it and then, yeah. So we have the function to validate user operation. But in this case, right, so this validation data we're talking about, for this class, we are just going to allow all transactions to go through, right? So since we know we are the ones sending it, so we are not going to like put these checks. And of course, the validation data, of course, is to make checks to verify that only some certain allowed externally owned accounts can actually call this function. But in this case, since we want everything to go through, so we are just going to return 0. Remember, the EVM understands zeros and ones, right? So 0 is true, allowed everything. 1 is false, right? So we're just going to allow everything. And then we're going to have our simple function that is going to, let's call it execute, yeah. So our simple function that is going to something is missing. Okay. All right. So, okay. Yeah, I think that's for sure. All right. So we're just going to increment our count, say count plus plus. So just going to implement our count. Okay, I think yeah, let's look at this first one. The user operation, a function here is supposed to highlight blue. So let's look at here. So we're still learning, right? All right. So I think what I'll do is to take out all of this. I think let's take this out. We'll take this out. Yeah, and we need to make our function pure, of course, because we are not going to actually change the state of the blockchain. So we are going to actually make this function pure, right? So make it pure, and then it returns unsigned integer, right? Let it return an unsigned integer. So it returns let's just return unsigned integer 256. So here we can then return 0. Yeah. So this is what I was looking for. I needed this function to highlight blue. So yeah, I think I've gotten that. Yep. So we can continue. So we return 0, return 0, so that we are allowing all our user operations to actually go through. So then we now have our simple function. Let's call this external, since we are going to be calling it from our entry point. Remember, the entry point is actually going to call these functions and then have our smart account execute this. So we have to make it external, right? So yeah, I think we have that. These are simple smart contract that all we are going to do is set a count and then increment the count. But we want to use our smart account to do this and also verify that it is the smart account that is actually doing this. All right. So I think that's that. And then we need, of course, if we go back to the our documentation, of course, we have the user operations, we have our accounts, which we just created, which is our smart account. And then we have what they call an account factory here. So this account factory is going to help us instantiate our smart account, especially when we are sending user operations. So we'll see that in a minute, but then of course we can see that the account factory is actually also a component of the architecture. So we need to have another contract which we are going to call our let's call this our account factory, right? So in our account factory, what we are going to do is we are just simply going to create our smart accounts, right? Instantiate our smart accounts kind of. So we just have a function. Let's call this function create account. Yeah, sounds great. Yeah, create account. And what this function is going to do is going to take in an address of an owner. And in this case, the owner is going to be our smart contract. So remember, our smart contract is going to take in the address of our externally owned accounts, right? But our account factory is going to actually take in the address of our smart contract. So we'll pass in that address there, and this an external function, so it's going to be called by our entry point, and it's going to return an address, right? So it's going to return the address of the smart contract created. So let's return an address, and then yeah, so we now instantiate it by saying that our smart account, let's call this account, is equals to new smart accounts. Then we're going to pass in the owner, right? Yeah. So then we're going to return the address of the owner because we are returning the address here, right? So let's return the address of the owner. Yeah. So what we are simply doing here is that we are instantiating, of course, from our smart account here, we are instantiating it here. And then we're returning the address of this account that we have created, right? So we're creating a new smart account, kind of. So I think that's all of that we need for our smart account. In this case, the smart account here is this account we just did, and then this account factory, right? So we have our smart account, we have our smart account factory. So before we send user operations, right, we need an entry point, right? We need a smart contract that will act like an entry point where you can actually send this data. And of course, we're lucky enough because the guys at It Infinitism, of course, they made it very possible. So if we come back to our node models and look at core, so we see that there's a contract here called entry point, right? So this entry point inherits from entry point, the state manager, the nonce manager, and of course, there's a reentrancy guard, right? So, but in this entry point, you see that it has tons and tons of functions, right? So, but the only function we are going to be calling here is going to be to handle user operations, right? So, because let's go back to the documentation, let's see what the entry point does, right? So this is the entry points, a smart account that handles the verification and execution logic for transactions, right? So basically, that's what our smart account, or rather, that's what the entry point here is for, and it has tons of functions. Like I mentioned earlier, we can do a lot with smart accounts, right? So, but for this class, we are just going to send a user operation, and of course, implement it with using our entry point. So we are just going to call, I'm actually looking for the function, it's called handle ops. I think I passed it. I think I actually passed it. But there is a function called handle ops. So it's kind of like handle operations right here. So you see this handle ops function. So it's going to take in our user operation and of course an address, right? So this address is going to be our smart account address. So I think, yeah, so we have our smart account and then our account factory. So the next thing we're going to do is we're going to go ahead to deploy our smart contract, of course, get our entry points from It Infinitism node package that we installed. That was the account abstraction slash contracts we installed, right? So if you look at our package.json also, you see right here that we have it here, account abstraction slash contracts. So Yeah, so now deploy our, okay, all right. I think this is, of course, when we created our HADA project, this deploy came with it. So we don't actually need it. So we're going to delete it, right? So we'll just delete that and then, yeah, we'll create a new one. So first thing we need to deploy is we need to deploy our entry points and then deploy our account factory. So let's call this deploy, let's say AF for account factory, right? So yeah, .js. So the first thing we're going to do, I think we're running out of time, so I'll try to be as fast as possible. So the first thing we're going to do is we're going to get an instance from our instance of Ethers from Hadat, right? So you can be able to actually interact with the blockchain from our local node, right? So because Hadat actually, like I said, is a development environment, so they actually kind of like help us run local Ethereum nodes on our device, and then they will give us access to some accounts, some private keys, and some fake ETH to work with. So yeah, that's that. So we're going to use Ethers from Hadat. Then we just need one function where we are going to deploy our account factory, right? So let's deploy our account factory. Call this function main. We're not going to pass in anything. So yeah, so what we are going to do is we're just going to get our contract. So we say await our instance of ethers.ethers constant. Yeah, yeah, let's call this AF for account factory, right? Okay, so ethers. So we're going to call a method that we'll call deploy. There's a method deploy contract, yes. So what does this method do? You say it takes the name of the contract and optionally a signer, right? So where are we getting this from? If we go, we'll click this, of course, we see it here, function deploy contract, it takes the name of the contract, and of course, it's going to deploy this for us locally. So yeah, we are just going to pass in the name of our the contract we want to deploy. In this case, what the contract we want to deploy is our account factory, this contract, right? So we just get the name and then pass it there, right? And yeah, that's it. Then we just wait for it to deploy. So we are going to await AF dot wait for deployment. Yep. So it deploys and then we just console log the address of our account factory. That's it. So let's get the address. Let's say address. Okay. Let's account factory address. Account factory address. Yeah. So we're going to pass our deployed account, which is AF, then we're going to get the target. So the target gives us the address, right? So AF.target will actually give us the address of our deployed smart contracts, sorry. So then we are going to call our main function, and then if we catch any error, okay, let's just check, right? So we'll catch any error. What you want to do is you want to see that error. So we console log the error. Then, of course, after that, we proceed, right? So process.exit code. Yeah, so equals 1. So if we catch any error, we want to see the error and then we want to return. Of course, we don't want to continue. So yeah. So awesome. It's time to test what we've done so far, right? So let's first and foremost, we need to start our hard local node, right? So the way we do that, we do npx hard node. So what it's going to do is going to start a local node for us, give us some addresses, give us some private keys. And yeah, I think I have an issue, an unexpected error, cannot find model or what could be the problem? Let's see. Which model? Model not found, model not found. MPX file node. Okay. Yeah, so these things happen, right? Great. So today we are here. Let's see. Wow, same thing. Okay. So let's check our package.json. What's missing? We have the toolbox, we have Haddad. So, okay. Let's see. Oh, okay, so I think we're having a problem. Let's check. What's the problem. Oh, yes. Yeah, this happens sometimes, right? So you know why we're having the error is because we have not configured our header to actually run the node locally, right? So I think that's where our error is coming from. So how do we do that? Yeah, we'll go to our hard config file. Yeah, I was right. So this latest Solidity version is 0.8.24. But yeah, what we want to do is now is want to change all of this. And then let's see, let's configure first our hard config file so that we can run our nodes locally, right? So how do we do this? We need to take this out first, right? So let's tell Hada that the default network we want to use is our local node, right? So our default network should be local node, local host, sorry, we said local node, so we're having local host. Yeah, awesome. So what else we want to specify our Solidity version? Yeah, so now we can specify, and then we'll just add some optimizers, right? So that we can run our code more efficiently. So let's specify the version. What version are we really using? We're using version, okay, 0.8.9. All right, so okay, so just say, okay, yeah, awesome, greater than any version greater than 0.8.9 or 0.8.9 and upwards. So what was there before? I think we'll just leave it at what was there, 0.8 point, I think, help I'm not wrong. So yeah, so the next thing we are going to do is let's just get some optimizers so that our code run more efficiently, right? So optimizer, let's say optimizer, yep, let's enable it. So let's enable our optimizer. Then, all right, let's just set our run to 200 so that 2000. So that, yeah, I think that's for our hard hat config. And then let's go back to our deployment. Let's see if it comes up, right? So npx hard hat node, yeah. Same thing. What's the problem? Cannot find this model. Oh, Okay. All right. So just a minute, guys. I'm just trying to figure this stuff out. Sometimes this happens, right? So we need to actually run our local nodes so that we can actually use so same thing. So okay, what I'll do is I'll try to find, let's see, let's work with this together, right? So let's try to find this model, FTS lead beta. So let's see, let's try to find this model. Okay, it represents a value of one or two possible types, a disjoint, an instance of eta, and all of that. But okay, great, awesome. All right. Let's try something. Let's try something. Let's be sure that our hardware is completely configured. So let's try to compile our code, see what happens. Same thing. Okay, so it has a problem with our installation, right? So okay, that's awesome. So I think we need to go back here and then see what we missed out. What did we miss? What did we miss? 4.0.1. Yep. Okay, that's awesome. Just a minute, guys. 1 minute. I'll look at your questions, and then while we are that, you feel free to ask any questions you want. No curly brackets in the first function. Which function is that? So please, if you have any questions,
You've rectified it already. You've rectified it already.
I've rectified it. I think our issue is with our installation of Hadat. I know when I was installing, I had one or two network issues. So let's just see what it is. Just a minute, guys. Just a minute. I'll be with you. Let's try to see what really happened here. So, okay. Yeah. So in the meantime, please, let's not just be silent. I'm hoping you guys would have questions by now.
I actually have lots of questions.
Sorry?
I said I have lots of questions actually.
Please feel free to fire. I'm listening. We can fix this at the same time.
Okay. So how about someone that has no idea about blockchain? How does it cope with all the information it's getting?
Of course, all of these I'm saying I'm heading somewhere, and at the end of it, we'll be able to understand exactly all what I'm trying to say. And for someone that has no prior knowledge of blockchain, of course, you always have our resources. If you go to our YouTube page, there are tons of resources that can help you catch up with blockchain.
Okay.
So please feel free to also, in your spare time, go to our YouTube, and then there are tons of resources that can actually help you out with that.
It's really interesting.
Okay. So Okay, 1 minute, guys. I think, yeah. Okay, so I think I actually figured it out. Yeah, awesome. Deploying, right? So, yeah, I'll just share my screen again right now. I think I have that. Uh, okay, so back to what we're saying. Yep. Okay, so I'm just trying to make sure that what I'm trying to do, I'm updating. What I'm doing is that I decided to update my package, right? So I'm reinstalling everything just to make sure. But I think I'll know this up. So that's awesome. That's awesome. I'm just reinstalling everything I installed. I think probably when I had the network glitch, some things didn't quite install. So we didn't have a full harder package to work with. So, but that's fine. So I'm still installing. It's almost done. Just a minute or two. It's almost done. Okay. All right. So we are back. Let me share my screen. Yeah. Okay. So, yep. Oh, can you hear me? Can anyone hear me?
Yeah, I can hear you.
Yeah, I can, sir.
Okay. Awesome. So I'm sharing my screen. Sorry, guys. I had to reinstall all of my packages because I think the initial one was messed up. Like I don't know what really happened there. So uh okay, this is my VS Code and my Chrome. So awesome. All right. So guys, can you see my screen? Can you guys see my screen?
Yeah, I
Yes,
can see
boss.
your screen.
Okay, awesome. So what really happened is that I had to update all my packages again and it's fine. So all right. So I was saying that we need to first start our local node. So to do that, I said we'll run npx add node. Hey, I'm using double N this time, so I'm expecting an error, which is yeah expected. So this is node with one N. Okay, awesome. So this is it. So now we have that gives us all these wallet addresses. I think about how many of them to be 20, right? Because it starts counting from zero. So yeah. So this is the private key and then this is our wallet, right? So basically we are going to use this local node to actually test our account abstraction, right? So I think I commented, I even deleted it. So okay, let's just get it. Let's deploy it. Call this let's say account factory address. This is our account factory address. And then we're going to pass in our AF. Yeah, awesome. Then we call our main function. We're not passing in anything. Then if we catch any error, we want to console log the error. Want to console log the error. And then after that, we want to end the process and then return, right? So process.exit code. And then we want to pass in one so that, yeah, it does that for us. So great, awesome. So yeah, now we've started our instance of our Haddad local node. The next thing we'll do on another, of course, terminal, of course, because we need the node to be running while we are doing all of this. So we're going to deploy our account factory. So we're going to run a command, npx Haddad run script. So basically what we're telling Haddad to do is we want Haddad to actually run this script. We're going to specify the script, but we want it to run from this deploy. All right, okay, so I haven't made an error in the file. So this is supposed to be .js, not .js, .js. Okay, great. So we're going to run our deploy and then, yeah, that's it. Yeah, so we just wait for it to deploy and then we get the address. So, oh, all right, this is supposed to be .target, right? So we couldn't get, so let's deploy it again and get the address. Yeah, we didn't specify, the target gives us the address. Target. So we're having an object. So why is that? Okay. I didn't save the file. It's funny. Today is crazy, man. But it's fine. All right. So I'll eventually this is going to give us here. So yeah, we have our address here. So now what do? We just get this address. Let's just save it here and call this our account factory address. Let's comment it out. We'll be needing it very soon. So this is our account factory address. So the next thing we're going to do is we're going to deploy our entry points, right? So the entry point is going to handle all the validation and then, of course, ensure the transaction actually goes through. So to deploy that entry point, we didn't create a contract for entry point, right? So what we're going to do is that we're going to go to our node models and then if we go to our core, then we see entry points, right? So we are going to get this contract here, this entry point contract. Since we are importing it in our contract, we can easily deploy it, right? So in our script, we are going to have another file. We are going to call this, let's deploy entry point. Let's call it entry point, EP for entry point.js. So exactly the same thing we did here. So I'm just gonna go ahead and copy this. Yep. Yeah. So we don't need you, but we need you. So we just paste this and then we're going to change this to entry point. So let's call this EP. And then of course we're going to change this to entry point. Yeah. So EP dot Let's just change all occurrence at once. Yep, awesome. So now we're deploying the entry point, and then we are getting the address of the entry point. So the same thing we did, we run our npx add that run script, but this time we are not deploying our account factory, we are deploying our entry point. So then we'll get the address of the entry point, and then we're going to try to, I think time is well fast spent, so awesome, but no trouble, we can handle it. So this is the account of our account. No, I was supposed to change this to entry point. So this entry point, right? So, but then we have an address, so we'll just get the address, right? Because we are very sure that is the entry point, right? It's just that in our console.log, we didn't change that last part. So this is our entry point. So entry point address. So yeah, awesome. So now let's go ahead to try to, of course, execute user transactions and then set up our user operations. That will be the next thing we're going to do, to set up our user operations. So we're going to do all of this in a script, right? So I'm going to try to be as fast as possible, but if you have any questions, please feel free to ask your questions. So let's have another script. Let's call this script execute. Yeah, I like execute.js. So yeah, in our execute.js, of course, first thing first, we need our instance of Hadad to be able to integrate with this, right? So let's get that instance. We need Hadad. Yeah. So yeah. So then we have our, of course, our function main. We're just going to have one function, and this function is going to do everything we're going to try to do, which is we're going to try to change the state of the blockchain using our smart account. So all right, so the first thing we actually need to do is to get the address of our entry point and our account factory, right? So let's say our account factory, or let's say, yeah, account factory, right? Account factory address. Account factory, and then we get our address from our account factory. And we do the same for our entry points. So entry points, we get the entry point address also. All right, so now remember we are trying to execute a user operation. So we now go back to our Chrome. Yep. So let's see what we need for our user operations, right? So we'll go down to account factory. Okay, yeah, user operations. So in the user operations, this is all the field that we will need, the parameter that we actually need to send to actually of course, execute this user operation. We need the address of our smart contract. In this case, the address of our smart account. So we need a nonce, and of course, the nonce will act as the sort. And if it's the first time we are going to deploy it, we are going to use what they call an init code. So the init code is actually it's the hash of both our address and some parameters added to it. If we go to our node models, I'm trying to be fast, but I just have to explain these things. So if we go to our node models, I think, is it core? Let's check the interface. Okay, nonce manager. So increment, no. Core, nonce manager. validate and get known. But basically, the nonce is acting as an anti-relay, right? So it's acting as an anti-relay so that we can validate that this is the smart account. This transaction is actually coming from this smart account. We can verify that. And of course, the core data, the gas limit, the maximum gas limit. We're not going to use all of this, right? But we're going to actually, this is what the user operations look like. So we need the sender, the nonce, the init code, the core data, and all of this. So yeah. So what do? We are going to first create our user operation. So let's say const user operation, user up, member. Then what do we need? Let's see. We need the sender, the nonce, the init code, the core data, gas limit. Okay, so we need the sender. And we need what again? The nonce. And then we need the init code. We need, I think, something called core data, right? So we need the init code. And then we need our core data. And what else? Let's see. Gas limit. And so I'll just go ahead and copy this, right? So gas limits. What else? Verification gas limits. Pre-verification gas. Okay. So we have the verification gas limits. And then pre-verification gas. Pre-verification gas. Yep. And then after then, we have maximum gas fee and maximum priority gas fee. Max fee per gas first, yeah. So we have the max fee per gas. Then we have the maximum priority fee per gas. And then we have the paymaster and data, and then we have the signature. So, but for what we're trying to do, we are not actually going to implement the paymaster. So we're just going to fill some dummies for this, and then we have a signature. Awesome. Okay, so let's start with the first one, the sender, right? So the sender is actually our smart account address, but this time around is going to be the hash of this smart account address and then our nonce, right? So that means we need to have a factory nonce to actually execute this function. We need what we call the factory nonce for validation. So we're going to come up here again, and then we're going to get first and foremost the noun. So let's say factory nonce. So const factory nonce. Let's call it fact nonce. Fact nonce. Let's just set it at 1, right? Since we just want to validate one of these transactions. So after that, we need to get the sender. So the sender is our smart account, is the hash of our smart account, and then of course the hash of our smart account and the nonce. But before we get that, then there's a little tricky thing. We need to get signers, right? So remember, we are working from our local hard hat node. So we need to get the address and the signer. So the first thing we need is signer. So we need the signer to actually, this signer is the address that is going to actually act as the owner of everything, right? The owner of our smart account. So we need that signer. So we are going to get it from our hard hat local node. So sre.etas, then we get signers. Get signers, yeah. So it's going to return the first signer, the first account with the private key as signer, right? So get signer does that. So after then, we need to get the address of this signer just to compare. So we get the address. Let's call this address 0, right? Because it belongs to the first account from our local hard hat node. So we are going to get it, let's say signer dot get address. Yep. So fine, awesome. We've gotten our signer, we've gotten the address, we've gotten our factory nouns. It's time to fill in our user operations. All right. So we have our entry point address, we have our smart account factory address. So the next thing we actually need is to get the smart contracts from our entry point and then our account factory. So when we get this smart contract from the account factory, we are going to use that to actually create our sender, which is our smart account. So first thing, let's get from our entry point. Let's say our entry point, let's call this EP, is going to be, we are going to get that contract from our local ETAS nodes. And we're going to call a function called get contract. I think it's get contract at, yep, get contract. Then we're going to pass in the name of the contract, which is entry point. And then we're going to pass in the address of the contract, which is our entry point address. Entry point, yeah. So, yep, I think, yeah, our entry point. So we've gotten our entry point smart contract, and then we also need to get our sender. Remember, I said the sender is going to be the hash of our smart account and then our factory nonce. So we'll say our sender in this case is going to be, we're going to get that using a function called, I think it's get created address, because it uses get created address, not to. We're not using address to, we're not create to, we're using get create address. Yeah. So it's going to create an address. What this parameter does, get create address, is going to create an address for us. We are going to feed it data, and it's going to use that data to create an address for us. And in this case, that will be our smart account address. So we are going to pass in both our factory address and then our factory nonce. So it has two parameters, which is the from parameters, and then we're going to pass in our account factory, and then we're going to pass in the nonce, and the nonce in this case is our factory nonce, which is 1, right? So factory nonce, which is 1. So what this is going to do is going to create our smart account address for us. So yeah, I'm trying to be as fast as I can, but if I'm too fast, please feel free to call me back and ask me any questions you might have. So now we have our sender. We are going to use our sender here, of course. And then, yeah, for the nouns, we are going to get our nouns from, we are going to get our nouns from a function. I think I saw it earlier in our node models. So if we go back to our node models, we'll check the iNonce manager. I think there's a function called getNonce, right? So we'll pass in the address and then a key, right? So in this case, what we're going to do is for our nonce, we're going to pass in, of course, we'll say awaits our entry point. In this case, our entry point contract, smart contract, because our entry point is actually going to handle the validation and of course push the transaction. So we are going to be working from our entry point. So we are going to get the nonce, ep.get, can get nonce, supposed to highlight, yeah. So okay, I think I spelled it wrong. So this is get nonce. And then we are going to pass in our smart address and then a key could act like a salt, right? So just passing 0 for now. Then the next thing is our init code, right? So if we come here, we see that our init code is the code that is used to deploy the account if not yet on chain. So our account is not yet on chain, right? So getting the init code is actually quite a bit tricky. But yeah, first we are going to get the init code from our account factory. So that means we need, of course, the address, the smart contract instance of our account factory. So let's get that. Let's say awaits, and same thing we did here, just get contract at. Okay, so get the contract. Okay, in this case, let's just get the contract factory and just specify the name of the contract, right? So let's get the contract from our account factory. Right, awesome. So what we're trying to build the init code, right? So if it's not yet on chain, we actually need the init code to actually go through. So the next thing we're going to try to get is our init code. Let's say init code. Now let's specify something else so that we don't have naming error. So we'll get our init code from our account factory. And then, yeah, so get the interface, right? The interface, and then we're going to encode our function. Which function is that? We're going to encode this execute function that we're going to call in the init code so that, remember, it's the code that is deployed before our smart address goes on chain. So I want to encode this function inside of our init code so that every time we send a transaction from our smart account, it should be able to call this function init code, right? So that's the function we're going to get. And to do that, we're going to use, there's a method called encode function. It's actually a hard ETAS method says encode function data. Yeah, this here. Encode function data, and then we're going to pass in the name of the function, which is execute. So we are going to execute that function. Yeah, I think we have our init code. Then we are going to pass in our init code here. Init code. Yeah, so see, we're trying to fill up our user operations. Okay. I don't know how many. Yeah, okay. Hello, sir. Can you hear me, sir?
Yes, I can hear you.
Okay, I was just looking at the time and I wanted to confirm if I should continue or if we should just, because the time is fast.
No, let's just round up.
Okay. It might take a little time, but
Continue.
Okay, all right. So here we've had our init code, and then the next thing we need is our call data. So the call data is actually the function in the smart contract we're trying to call, right? So that's our call data. So now we need to get that call data. Okay, yeah, I think I mixed that up. So for our init code, we actually need to call the function called create, which is from here, because we are dealing with, yeah, I think I mixed both up. So for the init code, we are supposed to actually call the function from our account factory, right? And if you check well, our account factory doesn't have a function called execute. It has a function called create account. So this is actually what we're supposed to pass in with the address, of course, with the address of this address, our signer's address. So I think I mixed that up. So I'll just correct this. So we're passing the create account, and then we're going to pass in the address of which you want this account to be created, right? So pass in the address 0, which is of course the our address that we've gotten from Haddad. Yeah. So in the same vein, yeah, I think that's that. Then for the call data, we are going to call this function, this execute function from our smart account, right? So to do that, what we need, we actually need two things. We need the address. We need to get an instance of our smart account, and then we need to call that function execute in our smart account from our smart account. So first thing, we need to get an instance of our smart account. So let's call this smart account. Yeah. I'm using the underscore because the name of our smart account is smart account, so I don't want the naming error. So the same thing we did when we encoded the function for our account factory, but this time we're getting from our smart account. So we just get, we say await, yeah, we'll get the instance first of our smart account, ethers dot get accounts, get contract factory, I think. Yeah, let's get contract factory. So I'm just going to use that to get the name of our smart account is, I want to mix this up, yeah, smart account. So we're going to get that name. So now we have an instance of our smart account, and then to actually call the function, what do we call this? Let's say, okay, let's say call smart account. Sounds cool. Call smart account. So now we want to encode this function execute because we want to change the state of the blockchain, right? So we are going to encode that function so that we can pass it as a user operation to our entry point, and then the entry point can validate that for us, right? So we're going to get it just the same way we did with our init code, but this time around, we're not going to add the address of our init code to it. We're just going to get it directly because we have an instance of our smart contract already. So let's say our smart account, yep, dot interface dot encode function data, yep. And the function data we want to encode is execute. So yeah, we've gotten that. So for the call data, we are going to pass in our, what did we call it? Call smart accounts. So we're going to pass in call smart accounts. So for the gas limit, we're just going to fill this one up, right? So we'll just specify what you know would be enough. We should specify, because this is going to be in way, the smallest unit of Ether, right? So let's specify like, let's say 200,000. That should be enough. And for our verification gas limit, the same thing. We just specifying what we are sure should be enough to cover for gas fees, right? So for the pre-verification gas, it's not always much. You can make it smaller. Although Haddad is kind enough to give us, I think, 1,000 ETH, so we can actually spend as much as we want. Then for the maximum fee per gas, okay, we can pass that. Normally, it's passed in GUI, right? So we have to pass it in GUI. So let's let's format it so that we can pass it in GUI. So we'll pass. Let's pass unit, not Ether this time. So we'll just pass. Let's say 10 GUI, right? So this would be like I think 1,000 or 10,000 GUI. Think, yeah. So I think that's okay for the maximum priority fee. Okay, let's just do the same thing. It shouldn't be much, but let's do the same thing, right? So we're just giving values that we know are sufficient enough to actually pay for gas fee. So for the paymaster and data, since we actually are not going to use a paymaster, we're just going to leave it blank or OX. It's just a convention to pass the OX. Then for our signature, we are not actually verifying who and which account can actually have access to this. Remember, we are returning 0 in our smart account. So we are returning 0 here, right? So we are saying that, right, let all transactions go through, no matter the user. So, but normally in a production case, this is, you shouldn't do this, passing 0 for signature, all right? So we have our sender, we have our nouns, we have our init code, we have our user operation. Yeah, awesome. We now have our user operation. So the next thing we need to do is, let's see, let's go back to the documentation after the user operation. Yeah, of course, that we can now call the encoded functions that we've encoded. Yeah, we can now call this execute function, this call smart function that we do. But just to be sure, right? So what I'll do is let's try to see some things for ourselves when we're running the code. So this is our sender, right? So let's try to console.log our smart account. The sender, of course, is our smart accounts, right? So let's try to see some stuff while we run the code. Let's call this sender. No, this is our smart account address. So that's our smart account address. We'll try to see that when we run the code. So we have our user operation and yeah. So let's try to actually send a transaction, right? So after getting the user operation, to send the transaction, we actually just have to call the handle ops function from, of course, our entry point, right? So just to confirm that, if we go back to our entry point, where is our entry point? Yeah, entry point, we have a function called handle operations, handle ops. Let's look at, yeah. So the handle ops takes, of course, our user operation and then the address, right? So the address is going to be, the beneficiary address here is going to be our EOA address, right? Our externally owned account address. So what it's going to do is it's going to handle operations on behalf of our externally owned accounts, right? Our EOA. So that's why you have this beneficiary here. So, but basically, this is the function we just need to call handle ops, and it takes parameter user operation and then the address of the beneficiary. So, all right, so let's call this transaction. Let's say our transaction is going to be, we're going to await it since it's a blockchain operation. So we are going to await our entry point, and then what do we want to do? We want to handle ops, right? So we want to handle ops, and then we are going to pass in, of course, our user operation, our user op, and then the address, our address 0. So address 0 here is going to be, let me just, if you come here in Node, so when I say address 0, it's going to be this particular address, the first address that we got from this address, the first address that we actually got from our local node, courtesy of Haddad, right? So yeah. So yeah, that's it. We send the transaction, and what do we want for the receipt of the transaction? Let's await it so that we ensure that it actually goes through. So we wait for it to go through. And then let's just console log some stuff so that we can actually see what's happening. Let's console log. Let's see, what do we want to console log? Let's say the transaction hash, right? So it's going to sign as the receipt. So let's say transaction hash, and we're going to get this from, going to pass in we're going to await it since it's a blockchain event. So we await our transaction dot the hash of it. And then I think that's that. Okay, let's just also confirm where the transaction is coming from. And of course, the block number of the transaction, just to be sure. So we have the transaction hash. Let's put this in a new line, right? Instead of comma. So let's put this in a new line. And then we want to know who the from, right? So who sent this transaction, who executed this transaction, so that we can compare it, right? So it's going to be the transaction that from. And then the last, I think that's fine. We don't really need the block number, but you can also get the block number, right? So here we have, yeah. So something is wrong. Why something is wrong? Okay, I haven't called the main function. Yeah, so we have to call our main function to actually run our code. So we will catch any error as normal. We are going to try to see what the error is. And we should console log the error. And then after that, we should revert the process. Exit code. Yeah. So this is one. Yeah, awesome. Okay. So let's just go through it, make sure everything is, we have our signer, we have our factory noise, we have our accounts, we have our unique code, we have our smart accounts, and then we have our call account. We created the smart address, the smart contract, our smart account, not smart contract. And then we got our user operation and the sender. Okay, all fields. Yeah, very important, right? Very important. Now, in creating, see, we are not using a paymaster, right? So we need to actually send some funds to our entry points, right? So that the entry point can be able to actually execute this on our behalf, right? So remember, we are not having a paymaster. So since we are not having a paymaster, we actually need to create we actually need to send some funds to our entry point account. So I think let's just include that. You know, it's going to throw an error, right? So let's just see what I mean, right? So let's clear this up and try to run our execute script. npx adapt on script execute. So I'm expecting we have an error because our account, our entry point has no funds to actually pay for this transaction. So yeah, okay, this is a typo on my part on the GUI side. Yeah, so I'm not supposed to add this here. Awesome. So I'm expecting an error actually because our entry point transaction tx.nonce, where are we getting this error from? Invalid biggish number tx plus nonce. So this is our nonce here. Transaction.nonce. Okay. Yeah, like I said, I was actually expecting some error. So let's first of all send some money to our entry point, right? Let's send some money. So let's deposit. Of course, Hadad has given us enough, so let's just deposit some of it. So we say await our entry point dot there is a function called I think deposit to cause deposit to, I think, yeah, deposit to. And this function comes from, of course, our entry point in our node models, right? So if you go through it, like I mentioned, there are tons and tons of functions you can use, and just go through it, and then you see that this is what I mean. This is what I mean here. So if we go back to our node models and we go to our entry point now, you see that entry point has a lot of functions, right? So we're actually calling one called deposit to, I hope it's a lot. If you look at the corner here, you see that it's a lot of code, right? So we're actually running out of time, but there's a function called deposit to, and this function would allow you to actually send some value to our smart accounts, of course, through our entry point. So we want our sender to be a beneficiary of this, and in this case, our sender is after creating the sender, let's do this here. In this case, our sender is going to be the recipient of it, right? So we're sending, how much should we send to our entry point? Let's say value should be, let's format it so that we'll be sure of what we're sending, right? Let's pass it this time around. Let's pass, let's say 100, right? So let's just pass 100. So we're sending money to our entry point, and yeah, yeah, I think that should work. Let's try to run this again. Oh, past it's, yeah, another semicolon where it shouldn't be. Okay. Yeah, so sometimes these things happen, right? So I just hope I'm not missing any parameters. We've passed the unit, we've called our core data, init code, gotten the nonce, and this is our sender. So we're having invalid bigish number, and where is this coming from? It's coming from type error value. Our value is non-invalid arguments, and this is coming from contract address. Okay, great, awesome. So let's look at it once again. I think we're missing something. Let's go over it. So we have our account factory, we have our entry points. Yep. So we have our account factory. Okay, and we have our entry point contracts, just to be sure. Okay, and then we have our sender. We couldn't even console log the sender, right? So I think this issue is coming just before then. Whoa. Okay, this issue is coming just before then. Yeah. Well, I think my battery is, wow. Just a minute, guys. I need to, I think my battery is down. Hello, sir, can you hear me?
Yes, I can hear you.
I think my battery is like 10%.
Okay, so let's
No
trust
power. Yeah. So probably we could just continue this in our third part. We'll do this first, then we'll continue with the paymaster.
Okay, so guys, it's been a very engaging time. So let's just continue this discussion on the Discord, on the Telegram as well. So tomorrow we'll be having blockchain developer Uche tomorrow. So and then we'll be looking at building your first wallet and testing it on Arbitrum. I know you don't want to miss it. Same time, it's a little bit slightly different. 8 p.m. We'll be starting 8 p.m. tomorrow. So on this section, we can as well have either we have the taught sessions or we have a recorded session and upload it on the channel. So it's been a wonderful time. Thank you, Etete, for making out time. And Wisdom, you guys have been awesome. I don't know if you have any questions. Our friends online, we just want to appreciate you guys too. So let's get our hands busy. Do we have any questions? If not, I think we're far late, so we cannot entertain any questions. All right, Wisdom and Osinachi, you guys are the winner for today's bounty. Okay, just do us a DM with your MTN number, so we'll just send you data. Congratulations and signing up from here. Bye.
Thank you. Bye also.